Alright, so here we go with 6.4. Now we get to equations here. And if you think about it, we've been getting to equations with every single form that we've learned. Remember that with in chapter 2 we did it with linear equations here. We learned how to solve linear equations. Then we learned about polynomials. Once we learned about those, we learned about factoring. Then we're able to solve equations that involve factoring here. Well, this one is equations involving rational expressions here. So anytime you see fractions inside an equation, we want to solve for the x. Example number 1 actually still comes from chapter 2. This is not a chapter 6 problem yet. We'll see the difference here in a little while here. But it does give us a good introduction to it here. So if I see fractions, what I do is I multiply by the common denominator, and I get rid of those fractions here. So I see a 3, a 2, and a 2. I'm going to multiply both sides by 6 and see what happens. That's the whole concept here. So multiply both sides by 6. I could either multiply both sides by 6, or what I can do, probably the easier way to do it, is just to multiply every single term by 6. And then you're just sort of canceling stuff off like this. The 3 and the 6 reduced down to a 2x. How about the 2 and the 3 reduced down? I'm sorry, 2 and the 6 reduces down to a 3, so 3 times 5 is 15. And then over here, 2 and the 6 reduced down to a 3. 3 times 1 is 3. And notice this right here is a whole bunch simpler to solve now. So we're really going to be practicing that little initial step, multiplying through by that common denominator. Alright, the reason why I say this is not a chapter 6 problem but a chapter 2 problem, because there's no variables in our denominator, because we've been practicing ever since we started chapter 1. We've been practicing with variables being on that bottom, or in that denominator. Alright, but let's go with it here. Let's go with the easy one here first. All yours. X divided by 2 plus 3 divided by 5 is equal to 1 divided by 5. When does that happen? Alright, common denominator is?
10.
10 is good, yep. Let's multiply both sides by 10, but what is the easier way to do it?
Multiply 10 by each.
Multiply that 10 by every single term that we see. So 10 goes there, so 10 goes there, and there. Alright, again, 2 goes into 10 5 times. Then we got 5 times x. Perfect, yep. 5 goes into 10. Awesome. And 5 goes into it twice, so 2 times 1 is 2. And then finishing out. Once you get to this step, I think the rest of it's so much easy. Right. So subtract 6 from both sides gets you a negative 4 divided by 5, and you get your final answer of negative 4/5. Okay, and before we get to the sort of the normal basic ones, we're going to do one sort of quick one that you can always do with these rational equations here. Cool. Alright, let's talk about it here first though. So I have this 4 over x minus 5 is equal to 4 over 3. Now do you remember all the way to 6.1, remember we talked about something called a restriction. It's what x just doesn't make sense for x to be that number. So in this case, what would x, what's the restriction on x?
Multiply everything by x minus 5.
Before we multiply, 6.1 talked about, yeah, talked about there's a one number here that doesn't make sense.
X, right?
If x is equal to 5, that's the number that doesn't make sense, because if I plug in a 5 for the x, 5 minus 5 is equal to 0, and I got 4 over 0, and that's really just gibberish in mathematics. It doesn't mean anything. Can't divide by nothing. So, off to the side, what we're always going to do is we're going to do this. We're going to say whatever our restriction is. So x cannot be equal to positive 5. It just would not make sense for this problem. Okay, so this is the quick one here, though. Whenever you see two fractions equal to each other, what we can always do is cross multiply. X minus 5 times 4 and 4 times 3. And that's a cross multiplication that we learned way back when in algebra. So see two fractions equal to each other, cross multiply, and they are still going to be equal to each other. Alright, from here, all yours, go for it. Finish it off. I'm going to finish it off as well here, distributing the 4, multiplying the 4 and the 3, adding now 20 to both sides gets you a 32, and dividing by 4 gets you a final answer of 8. And now the only question is, can I accept that as an answer? Yes. What's the only answer I cannot accept? 5, because if it's a 5, then again it would just be sort of just gibberish. That's sort of it right here. So finish it off, look back just to make sure that's one of those answers you can actually accept. Okay, again, this is the quick one. This is the very easy one. Now let's look at number 3, which is more like the normal ones. This is the ones that we'll normally see here. So 1 minus 3 over x, which is equal to negative 2 over x squared. Again, still a very easy one to deal with here. So first things first, what can x not be or else causes problems?
X squared.
I need a value for x. I need like x can be equal to.
Squared. 1.
Okay, let's go for it here. So let's try 1. 1 is perfectly fine because this will just be 3 over 1. That's 3. That makes a number, doesn't it? 1 plugged in here would make it negative 2 over 1, so that's still negative 2. Negative 2 would work because if you put a negative 2 here, it would be 3 over negative 2, and that's still okay. Negative 2 also works here because negative 2 squared is a 4. Negative 2 over 4 is negative 1/2. That's still okay. So I'm still searching for a number that x cannot be. Positive 2, it still works because that would work here. That would be a 4. Negative 2 divided by 4 is negative 1/2, so it still works. I can give you a hint here, or no? I think 5 works. 5 is fine because if 5 goes in here, that's 3/5. That'd be negative 2 over 25, and that's a number.
0.
0 is good. Yes. No, 0 is not good. 3 divided by 0, is that a number?
No.
There's our problem. So 0 does not work there.
Do this problem?
Look at it.
You just need
0 plugged into here. You get 0, negative 2 over 0, that's our problem. Our restriction is that x can be equal to 0 or else we get undefined terms. Well, you can't divide by 0. The previous problem, let's kind of do a contrast here. The previous problem, the reason why it couldn't be 5 is because, again, see this little minus 5 right here? If you put a 0 into here, 0 subtract 5 is still negative 5. That'll be negative 5/4. That is a number in mathematics. But if it's x is a 5, now we're in trouble because 5 subtract 5 is a 0. Now we got a 4 over 0, and that doesn't make sense in math. Okay, good there? It's whatever will cause a 0 as you've simplified the bottom.
So 0 cannot be the denominator.
So, yep, since you're not adding anything to x, you're not subtracting anything to x on the bottom, right? It's just whatever x is, that's what's going to be the denominator. So in this case, x won't be able to be 0 because that will cause it to be gibberish.
So it's always going to be, the restriction's always going to be 0 unless you have something that does something to that
Yep,
variable?
if you're adding 7 over here, if it was x plus 7, then x can't be negative 7. Because when you plug it in, it'll cause that 0 to be on the denominator as you simplified everything. Okay, we'll work on that for a little bit here. Okay, next is what's my common denominator? X squared, yes. So I got x to the 1, I got x to the 2, and I need x to the 2 to become that common denominator. Right, let's multiply everything, or each of those things, by x squared. So let's multiply. Let me rewrite the problem real quickly here. And let's go with multiply that by x squared, x squared, x squared. Alright, x squared times 1 is x squared. Good there. Okay, this one's going to get a little bit complicated here. Let's see. X on the bottom cancels. On top,
X.
I still have an extra x left over. And careful, careful. See this little minus sign? Make sure you bring this guy down. X times 3 is 3x. Equal to? What's going to happen?
2.
Perfect. Yeah, the x squareds cancel themselves out. Therefore, I'm just left with a minus 2. Can you finish off this problem?
Could you move the 2 and then the whole equation is equal to 0?
Absolutely, that's what I would do. And the reason why it tells you to do that is because you have a x squared term. Then you also have an x term. So you have to be factoring. So move everything over, set equal to 0. And let's see if we can factor this guy out and then get our some answers. Yep, we got it. Good. So I need two numbers multiplied at positive 2, but when you add them together, it gives you negative 3.
Negative 2, negative 1.
Negative 2, negative 1, yep, perfect. Or negative 1, negative 2, which whatever you want to put first. All right, if those are my factors, real quick here, can you tell me what my answers are?
2 and 1.
You guys are cool. 2 and 1. Okay. Can I accept both of those numbers? What's the only number I can accept?
0.
0. Awesome. So that means that that's it right there. Which is kind of strange, because if I have this right here, this is my equation, it actually says two different numbers would work. A 2 would work for this situation. A 1 would also work. So if you plug in a 2, both sides will equal each other. If you plug in a 1, both sides will still equal each other. That's just kind of funny to me. That's all. All right, let's go with number 4. Okay, if you want to stay ahead of me, all yours to stay ahead of me if you can, or if you want. Lots of steps here, so let's go through the steps here. First and foremost, though, let's factor our denominator as much as we possibly can. All right, let's go with it. Hopefully that was enough time here. But the only one that factors is the first fraction. Everything else remains exactly the same. And now we have a sort of an idea here. What numbers would not work for x?
Negative 2 and 2?
Perfect. Negative 2 won't work here. Positive 2 won't work here. And then negative 2 won't work here, as well as positive 2 won't work. So off to the side somewhere, you just put x cannot equal 2 or negative 2. We won't be able to accept those answers. All right, once I get that down, so what is my common denominator?
X plus 2.
And
X minus 2.
you got it. So here it is. Again, it looks weird at first, looks humongous at first, and right after this step, it's going to look a lot easier here. So let's multiply every single term by x x plus 2, x minus 2, x plus 2, x minus 2, x plus 2, x minus 2. So there it is, multiplying the terms.
Why do you like to multiply it to the first one if it already has?
Yeah, the question is why you multiply to the first one, because I want them to cancel. I want to see the cancellation process take place. So canceled, canceled, now I'm just left with x. Good question though. Okay, next term. Let's see, first of all the minus sign goes down. And the x minus 2 is cancel. Okay, kind of careful right here. Careful so you don't multiply two things too fast. Because this minus sign is subtracting this whole entire thing here. So when you multiply by 2 times x plus 2, make sure that you still, this is why I don't multiply it in my head, because this little minus sign might just disappear on you. The minus sign comes down, the 2 comes down, x plus 2 comes down, and then we're going to multiply this a little bit later. Let's go on this side. What cancels here? X plus 2, and then we got x minus 2 times 1, which is x minus 2. Alright, the rest should be easy. All yours. Alright, multiplying the negative 2 in, and careful it is you multiply with the negative 2. So negative 2 times x, negative 2x, negative 2 times a 2 makes a minus 4. So make sure you get that minus 4 in there. Check your work, make sure you have a subtract 4. That's probably the often made mistake by students right here. Okay, so simplifying each side, x minus 2x makes a negative x minus 4 still. Everything else remains the same. And now finishing it off. You can go numerous ways here. What I did is I subtracted x from both sides, which gave me a negative 2x. Brought it up here. Just rewriting it, make sure we can have some consistency here. Alright, let's see what are we going to do. What are we going to do? We're going to add 4 to both sides, which is a 2, divided by negative 2. And we get ourselves a negative 1. Alright, and another one here. Second to last problem here. Alright, let's see, do we need to factor our denominator? No, cool, it's already factored form. Awesome. What can x not be?
5.
Can't be a 5, there you go. And not possible, that'll be a 0 there, a 0 there, we're in trouble. Good there. What's our common denominator?
X minus
2.
Cool, and you also need the 2 there, x minus 5 as well as the 2.
2x minus 10.
I would probably keep them separate because we're going to be canceling things. So I multiply them together if we're going to separate them anyways. So rewriting the problem here and putting now x minus 5 is a factor as well as 2. So every single term gets multiplied by 2 and the x minus 5. 2 and the x minus 5. And 2 and the x minus 5. Alright, x minus 5s are gone, so I got 2 and the x multiplied together, it gets 2x. Over here the 2's are gone. This is looks like 5. That's the numerator, still multiplying the x minus 5. And again, I wouldn't want to multiply this in my head just because I'll probably make some mistakes here. Write them separately and then I can probably go from there. X minus 5's are gone here, but this one's easy. 5 times 2 is 10. Okay, everybody got to that step? And the rest is easy.
You distribute the 5 or you leave it like that?
The question is, do you distribute the 5 here?
Yes.
Absolutely, yes. You want to get rid of any parentheses, collect like terms on each side, and then solve for the x. Alright, so let me try it as well then. So distributing the 5 to the 5x minus 25. Gathering together like terms should give you a 7x on one side. And what should we do to solve for x? Add 25 to both sides gets you 35.
5.
Divide by 7 gives you 5. And it doesn't make sense. We can't have 5. It's gibberish.
So D&E?
Cool. D and E if you're online. The only thing I want to add extra here to this is if you had other answers here, then you would just choose that answer. Good. Remember how in the word problems we would sometimes solve things and we get like a -3 and I say you can't have a -3 for time. We get rid of that one, but we keep the one that we can use. So sometimes you might have that situation. We get two numbers here. One of them you won't be able to use, but the other one you still can. So that other one is the answer. Okay, in this case, I only reached one answer, and that single answer doesn't work. Therefore, it is no solution. D and E, if you were online with it. And done. Okay, next one. Let's see if you can go from beginning to end on this right here. All right, on this one, you don't want to cross multiply. All right, because if you cross multiply, look what's going to happen here. You're going to get a, you're going to multiply by a squared. Oh boy, this is going to be crazy. So you're going to get a to the third now. And that's going to be a lot of thinking about stuff here. So let's do this here. Let's just do what we have been doing for the last 3 problems. Let's, as much as we can, simplify or factor our denominator. So first denominator is a on the outside, a plus 3. -2 on top, a squared minus 9. A plus 3, a minus 3. Good, good. Awesome. What can a not be? Perfect. 3 and -3 or -3 and 3, whichever order you like. All right. What's my common denominator? So I need this a. First of all, this little monomial right here, right? This a. A is also it. Ooh, sorry, I forgot one. Sorry. 3, -3, and then I got an extra one. Where did the 0 come from? It came from this one right here. Right, there's my 0. That can't be. This is my -3. That cannot be. Again, -3 again. I don't have to list it down twice. And then I got myself the +3. That'll cause problems. So careful with that 0 there. Now let's multiply. I need the a to multiply with. I need the a plus 3. I need the a minus 3. Alright, everybody okay with our multiplier? Why we chose that multiplier? Alright, whatever we do to one side, we better do to the other. So a and the a plus 3, then the a minus 3. let's see, a's are gone. A plus 3's are gone. So really this is a minus 3 times a plus 2. On this side, a plus 3's are gone, a minus 3's are gone, so left with an a on top and a negative 2, so how about a negative 2a? Alright, all yours. FOIL the left-hand side out completely. FOIL, FOIL, FOIL. Set equal to 0 and see what you can solve for. Alright, let me start as well here. See if I can catch up to you. So a times a is a squared. This is the first FOIL, f of FOIL. Then a times 2, or 2a. Negative 3 times a, the inside terms, negative 3a. And then last term is negative 3 times 2 is a negative 6, or a minus 6. And let's gather together like terms right here. So 2a subtract 3a. Negative a or minus a, that'll work. Alright, next. Yeah, let's add this part right here over to the side. Finally set equal to 0. So plus 2a plus 2a. And let's see what I got here. Negative 1 plus 2 plus a, perfect. And I think it's time for factoring here. So let me rewrite this again real quickly here. Positive 3, negative 2. I think I'll go with that. Positive 3, negative 2.
Negative 3, positive.
Yes. Negative 3 and 2. Perfect, yep. A cannot be a negative 3 because of our restriction here. I can't accept the 2. Hey, we were talking about that last problem, right? If we have 2 problems here, restriction may have to tell us that we can't choose one of them. But if we still have any answers still left over that fulfills the restriction, that means we're good shape. There it is. A is equal to 2.